So I'm Andrew. My project has the awesomely unimaginative name Portsim. It's a portfolio simulation piece of software. I'm starting out as just having it being an add-on for MATLAB because that's I feel like the easiest way to get it to researchers and students. They just download my M files and they can immediately run it if they have MATLAB. But potentially in the future, I could port it using something like NumPy or Octave, which is like completely open source, and more people would be able to use it then. But since I'm targeting, students and researchers, I thought using it as like a MATLAB add-on made sense. My objectives are to create a piece of software that will allow researchers or students to construct a portfolio of stocks and then analyze its performance. And they'll be able to use different algorithms to do so, which is kind of important for the researchers and students learning the difference between the leading, construction algorithms. It's kind of for finance and computational finance students. I also want to be able to use randomly generated data, but it's kind of complicated. And then obviously display different metrics that make sense for analyzing performance. You want to look at rate of returns and such. And I kind of want it to be scalable because it's possible to do some of these calculations in a simple spreadsheet program, but as you start getting it into larger and larger portfolios and more stocks, or more and more, you make the time period longer and longer, you look back 10 years or something, it just doesn't make sense to use a spreadsheet program. It'll be too slow or just too cumbersome. And so, why is this worthwhile? There's a lot of financial software out there. Obviously it's a big thing in Wall Street, etc. A lot of big companies, Bloomberg and FactSet, etc. They make all of their money practically providing this kind of software. But those are really expensive, and it's for it's for analyzing future performance. In the most case, you want to be able. They try and construct portfolios that will make money in the future. This is a simulation, so it's looking at, you construct a portfolio in the past, and using data that you either generate or provide to the program, it'll tell you the performance. So you want to look at, you're looking more at what is the algorithm doing? How are the different construction algorithms performing against each other? You're not trying to actually make money or look at expected profit. You're going to actually see the returns you're making. And I'm also saying that it's simpler once it's completed to use and more scalable than spreadsheet software. So I'm just going to walk you through, I guess, the process that I'm using. So you can either read the data from a file, right now I just have a text file, but it wouldn't be that hard to be able to read from a CSV. So if you have data that you put into like Excel or something, or some other spreadsheet program, you'd be able to read it into this, or generate randomly. And then the data is stored in matrices. I'm using MATLAB, so it has a lot of really useful linear algebra libraries. And some examples, you have the very simple date and time versus stock price. That's the most basic thing. What's the price of the stock at a given date? Correlation and covariance matrices. These tell you how do stocks perform in relation with each other, and it's really important for the various algorithms for constructing a portfolio. And then I have something called usable matrices. This is something I use because if you want to provide some other kind of restriction on your portfolio, say you only want to use stocks that are in the Standard & Poor 500 or something, then you could have date and time versus 1 or 0, basically binary matrix, whether it's a member of the Standard & Poor 500 or not, and then that tells you which stocks you're allowed to use in your portfolio. The construction, so you need to set the duration of the simulation. How long are you going to run it for? You're going to select one of the few different algorithms you want to use, or you can make your own algorithm. I made it pretty easy to add one. I just have basically a switch block that lets you choose a different algorithm. You would just have to define it in the way that I specified. You just have to return basically an array of number of stocks you buy, or no, the number of shares you buy of a specific stock. You have the construction parameters, like how much starting capital, how long you hold a portfolio before you construct a new one. and how much history to use. Basically, how far back do you want to look when you're constructing each portfolio. And the last part you'll just see in this next slide, really. This is kind of a diagram of what's going on. If you let the blue line be like the complete history of data that you have, the red line, they have special names. End horizon is basically the number of days you hold a portfolio for before you trade it in and you construct a new one. Then P horizon is basically how far back you look. So if we start our simulation at time t1, you look back P horizon days, and you look at correlations, covariances, trends, etc., and you construct a portfolio here. You hold it for N horizon days. You calculate the new value of capital you have, and you use that capital to construct a new portfolio, looking back P horizon days and holding for another N horizon. You continue doing this process until you reach the termination, and you'll be able to. Throughout the simulation, you're holding on to a bunch of different values. You're looking at like, what was the rate of return from my starting capital to here, from here to here. You're also looking at daily rate of returns and annual rate of returns. So you have different rate of returns. You have annual, periodic, cumulative, compound, and you're keeping track of all of that while you're running the simulation. And also drawdowns, which is basically what's the biggest drop you had from some peak. So it's kind of a measure of risk. And using this data, you're basically using that data, the like rate of returns, drawdowns, and a few others that I haven't implemented yet. You can calculate some other metrics that tell you how good your portfolio is. Sharpe ratios and Sterling ratios are basically risk-adjusted rates of returns. Kind of, if you have high ratios, it's better. And if you have lower ones, then it's saying, well, you're taking on a lot of risk for the return you are getting. And so this is aimed at students and researchers. They'll be able to run these simulations on the same data using different algorithms, and then look at how they might perform against each other. Because it's not just about one might have have a better cumulative rate of return, but then when you adjust for risk, it might actually turn out to have a lot more risk, and so be worse off in that case. So that's where I'm at right now. Special thanks to Professor Krishnamurthy, Professor Magdin Ismail, who's getting me some of the real data I'm going to be using, Sean O'Sullivan for funding all of us, and just the RCOS organization in general. Any questions?
Yes, we post in blogs regularly. How many of you have read these blogs? No one? At least I read your blogs, so at least you have one read there.
So, I haven't updated it. I have like a few updates, but I'm going to be...
Yeah, but you're also putting codes. I also looked at your code.
Oh, okay.
In your possibilities. That's it.
So I'm still kind of confused on the true purpose of this. Are you trying to, create and construct and research algorithms that, based on past data, would have created a very useful portfolio so that if you were to implement the algorithm today?
Yeah, sorry. It's like so. There are like some leading algorithms that different companies use right now, and it's like, how did they come about those ones? It's basically this is going to be a tool for researchers to look at the different algorithms or construct new ones, basically, that will provide, and then those would be then used in the present day. So it's basically letting you look at real data from the past, use your algorithm to construct a portfolio, see how it performs on a bunch of different metrics. And so then you get an idea of how the different algorithms perform in different situations. Like you can run this, the simulation through like, a recession or something, or during a boom period. Maybe different algorithms perform better in those different cases. And so it's the idea that for students, it shows them how the different algorithms work and actually show them returns on it, instead of just saying, oh, well, this is the portfolio it would construct. And then for researchers, it's actually showing them results. This algorithm produced these returns in actual values, or would have in the past. So you can maybe use that one in the future. It's like, well, this one performed better in a recession. This one performed better in a boom period.
So it's pretty much just a massive test cradle to help you analyze algorithms.
Yeah. Yeah. Wait a minute.
So you said you're using a CSV and other data formats. I was wondering why you weren't using like a Yahoo API or a Google Stock API.
Oh, well, because like with those APIs, they're more for up-to-the-date information. I guess I could integrate with that. Like, but this is using like historical data, and if you already have the like CSV file that has all of it, then I mean the API. I might look into that. They might have that historical data.
Yeah, they actually have historical data.
Well, then that might be better. I don't know.
And I mean, is this like a paper trading app where you can actually analyze the stock portfolio and measure the analytics on your trades, and like will the program make trades based on like that?
Yeah, right now it's simplistic. There's just basically when you construct the new portfolio, there's just some kind of transaction cost. It just assumes that you're able to buy whatever amount of stock you need from the other companies. It's some set transaction value. But a more complex version would do something like that. Maybe in the future. I'm still working on getting just all the basic parts. But yeah, that would be the more intelligent way, and probably the way that provides the better results or more realistic results.
Does your program have any trackable sort of stuff? I know MATLAB is pretty good.
Not right now. I mean, it'll display some trend lines, but that was kind of like my hope was to get all of the this like the calculations and such like done, and then I figured once I had that, I'd see where I was at. I didn't know if that was going to take the whole summer, etc. I would love to have it just be have like a nice interface where it could be very simple. It would just make it even simpler for like a student to use or something. Like just click a button, start new simulation, and then they just fill in the parameters, easy, and then it displays a bunch of graphics. I'd love to have that, and I know MATLAB has some really useful libraries, but that comes second.
I think if you're going to try and do compatibility, anytime you have MATLAB, you should always use Octave.
Octave, okay.
Yeah.
I had never used Octave before. I heard about it after I started this, and I was like, oh.
Yeah, it's basically a clone. So I mean, if you're already writing your stuff in MATLAB, that's totally fine.
Yeah.
It's just like if you want to make it open source,
Yeah,
it's basically a clone of it. It has like compatibility things.
So yeah, that's cool. I was thinking about that, make it really widely available. So that might be also in the works. Like, I mean, if anybody else wanted to work on something, GUI porting to Octave, I don't know. Maybe in the future somebody will take it up.
Well, Archimedes sounds really.
Yeah.
Doesn't have a great one either.
Any other questions?